So for this one, when I look at it, my initial thought is my axis and my function match. So could I just do disk method? So then I start looking at how would disk method look with this one. For disk method, my boundaries create an issue, right? So with my boundaries, I have y equals this function, y equals 0, but I'm revolving around this right here. So I'm going to have two r's first and foremost, right? I'm going to have an outer and an inner r because I'm not revolving around something that is right up next to it. So my boundary and my axis have a gap, right? So I'm going to have r squared minus r squared if I do disk. The other thing is they're going to be shifted. So I would actually have this function minus my axis of revolution squared minus this function minus my axis of revolution squared. So that's hideous, right? So disk is really, really ugly here. If I were to do disk, I would have to think about this guy. I'm just assuming he's first. Minus my axis of revolution and square that thing. And then I'd have to have my secondary function minus my axis of revolution and square him. Or vice versa. I mean, whatever order. I'm not even paying attention to what order I'm in right now. So disk is ugly. So then my next thought is, all right, I don't want to foil that. Could I just rewrite it and do shell? Okay? So let's look at what happens with shell, which is really the method they land on with your answer key here. In order to do shell, I have to rewrite this, okay? So to rewrite it, I'm going to square both sides, right? And it's going to end up being x equals 5 minus y squared. That's not too bad, right? He's not that bad. My r here is also going to be shifted. So my r is going to be y minus this number right here because it's the distance away from that. So my y is my y value, and how far away I am from -4 would be y minus that value. So my r here is going to be y minus a -4, right? And then I technically have a secondary function, right? I have this x equals 1. Since I'm now in terms of x, I have x equals 5 minus y squared and x equals 1. And so I have to do the distance between the curves just like I did way back when I was finding area between the curves. So my h is going to be these two subtracted, okay? Because I have to figure out which one's above it, which one's below it. By the way, this is the higher one, this is the lower one. So my h is going to look like this, 5 minus y squared minus 1. That's my h, okay? So when you think about the revolution here, my r is how far away I am from my axis. And my h, or my height, and this way it goes the other direction, so it's a little weird. My r looks like this, my h looks like this. So it's going to be the distance between the two curves. I now have two functions that I have to deal with, right? So this is actually going to be an easier method because I don't have to foil a radical. And so I'm going to do 2 pi rh here. So I'm going to say 2 pi, and we'll talk about this guy right here in a second. My r is going to be y plus 4 minus a negative. And my h, I can go ahead and do this and make it 4 minus y squared. Now I still have to foil to make my life easier, but that's not too bad. I know one of my boundaries is 0, right? Since I'm in terms of y, my boundaries need to be in terms of y. So 0 is one of them. How do I figure out my other one? Well, I just plug in my x and figure out what my y is. So if you plug in a 1 here, 5 minus 1, square root of 4, which is 2. You don't have to worry about -2 because we've already limited it to go only to y equals 0. So had it been not there and we were just figuring out where they cross, we could do -2 to 2. But it actually limited me and said, y can't be lower than 2 there. So I'm only going to go up to 2. This is the easier setup here, okay? Now from this point, hopefully you can do it. Foil, do your antiderivative by adding 1 and dividing by your new exponent. plug in your 2, right? So from here, hopefully that process is not difficult. But setting it up, you need to visually see, okay, what is the path of least resistance here? All right? You could have done it this way. That would be a nightmare, right? To foil and even to take the antiderivative of would be hideous as well. So getting rid of that radical is actually easier in this point. It's not always easier. Sometimes the radical works itself out in pi r squared, right? Sometimes you have a radical and you're getting ready to square the radical. It's going to go away anyway. But in this case, it wasn't pretty. So rewriting it to shell method was easier here. So here's the thing. If you look at your answer key here, they rewrote this and they did 2 pi RH, okay? My first thought is, why don't I just do disk method, pi r squared, all right? A couple of reasons why I would do pi r squared here. One, I'm revolving around an axis. The axis itself is one of my boundaries. So I'm literally going to have my function minus 0 as my r. And it butts up. So I'm just going to square that guy. So I actually did disk method here. I chose to do pi r squared because it's already set up that way. Okay? And so I am going to say, well, for this guy, it's already set up beautifully for pi r squared. So I'm going to say pi. My r is going to be the difference between these two. Well, that's 0. And so when you subtract a 0, it's really just that guy. So that's my r, square root of 2 minus y squared dy. I need to know my boundaries here. Now my boundaries are a little bit different. For boundaries, I know the 1, okay? I need to plug in the x to figure out my other y. So I'm going to say 0 equals the square root of 2 minus y. Square both sides, I get 0 equals 2 minus y. So y is going to equal 2. So my boundaries here are going to go from 1 to 2. And what's beautiful about this is this particular radical takes care of itself because I'm not adding or subtracting anything and then squaring it. I'm just squaring the radical. So I just have this little guy right here to worry about. And he's easy, right? 2y minus 1/2 y squared from 1 to 2. And you're going to get the same answer they did. They just set it up in a 2 pi RH for some reason. That's what they did in the answer key. I would leave it as a disk here. It's set up for disk. My disk takes care of the radical. Don't have to worry about it. It's not like the other guy where I had a radical minus something and then foiling that whole big thing. Nope, this is a much easier setup. Go straight to disk here. My first thought here. What do you think my first thought here is to do? Yeah, my first thought is disk, right? So let's look at what happens with disk. For disk, I have 2 functions here. I have y equals the square root of 6 minus x and y equals 0. Those seem pretty simple enough. These, however, are going to be shifted, correct? Why are they going to be shifted? Well, I'm revolving around this guy. You see that? All right, so what does that do to me? I'm going to have an outside r and an inside r, all right? And I'm going to go, my x values, I know I'm going to go to 2. If I were to plug in a 0 to figure out my other x, then I'm going to get 6, right? So I would go from like 2 to 6 for my x's. That doesn't seem too horrible. But then I have to shift each one of them. So one of my r's is going to be the square root of 6 minus x minus negative 2. And one of my other r's is going to be 0 minus a negative 2. So I have square root of 6 minus x plus 2 squared minus 2 squared. That is also gross, right? Do you see why this is not like my other radical? My other radical worked itself out. I didn't have to shift it and foil it, right? Now, I've already shifted one and it didn't matter because it ended up being just numbers that were subtracted. That's not bad. But when I have a radical in there and I'm adding and subtracting a number and then foiling, that's ugly. So as soon as I write this down to figure out that's what I would have to do, I'm going to see if the other way looks prettier. Immediately, I'm going to see if the other way is prettier, right? Before I even take 3 pages of paper to FOIL this and do the antiderivative and get halfway into it, and you have 4,252 over 75, and you're like, what kind of answer is this? I'm going to stop here and see if rewriting makes more sense, okay? So in order to do shall, I have to rewrite this one, and I'm going to use this as my other guy. It's going to be x equals, okay? Those are going to be my boundaries. And so I'm going to rewrite him. When I rewrite it, I'm going to get that x equals 6 minus y squared. My other function is x equals 2. Those are my 2 functions. Does everybody see what I did there? I rewrote it. Now I'm evaluating what shell would look like. So what would shell look like? Okay, well, shell is going to be 2 pi times r times h, right? My r is what considers this right here. So my r is going to be y minus that guy. My r is going to be y minus what I'm revolving around there, or y equals 2, or y plus 2 right there, right? That's my r. My h then is going to be the distance between those 2 functions. All right? 6 minus y squared minus 2. That's my r. I have to take these 2 functions and subtract them. That's my h, rather. So I get 4 minus y squared. Right? So in this case, even though I'm going to have to FOIL those 2 when I multiply them, it's still nicer than foiling this guy right here. He's ugly. I don't want to foil him.
How are you getting y plus 2?
So it helps. So in all those years that we did, like, what does this function look like? It does help to visualize the function. But even if you cannot visualize the function, you have to think about, for shell, what your r means. Your r is your distance from your axis of rotation. And then your h is your distance from axis of rotation using your functions, pretty much. Okay? Or the functions from each other, rather. So when you're doing disk method and you have an axis of rotation that's not, it actually is within each of your r's, but that's not true for this one. Your axis of rotation affects just the r piece of your shell, whereas the disk, they're both r's, so that's why you have to consider it in both of them when you do a disk method. We're not doing r times h when we're doing disk. We're doing pi r squared. So they're both affected by that axis of rotation when you have a shifted axis. That's why within the function, you add or subtract that line of rotation and then square it. Okay, so for shell, I'm going to say 2 times pi. My r is y plus 2. My h is 4 minus y squared. All right. Since all of these are y's, my boundaries are y's. So I know I have a 0, right? And then I need to plug in my 2 here, just like I would any other time, and say 6 minus 2 is 4, square root of 4 is 2. So I'm going to do it this exact same way. I'm going to use the other things they gave me to figure out what my boundaries are. Your boundaries should always match the variable that's here. This represents the variable for your boundaries. If these are y's, your boundaries need to be in terms of your y. I'm going to go from 0 to 2. I'm going to choose pi r squared because there's a gap between what I'm revolving around. I'm going to square them individually. Right? So if I plug in a 1, 2x is actually going to come first. I'm going to square him, right? X squared is actually going to come second. I'm going to square him. That's what he's going to look like. They actually did shell method here. I would not. I would do disk.
Shell method don't make sense.
So to find your boundaries, you're literally just going to say 2x equals x squared, set it all to 0, factor, and then you got your boundaries.